Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss surface areas and volumes. In this chapter, in the previous class, we have discussed the concepts of exercise 13.3. I hope you have learnt well the concepts of exercise 13.3, and I hope you have learnt the problems related to the concepts of exercise 13.3. Haven't you, my children? Right. Now come to the exercise 13.4 concepts. Are you ready to listen the class, my children? Right. In the previous exercise, we have discussed the concepts of a cone, what is meant by cone, and how to find the surface area of a right circular cone. Yes, or no, my children? Right. In this exercise, we are going to discuss surface area of a sphere. Okay, my children? Right. First of all, let us define what is meant by a sphere. What is a sphere? Is it same as a circle? Can you draw a circle on your paper? Yes, you can, because a circle is a plane closed figure whose every point lies at a constant distance called radius from a fixed point, and which is called the center of the circle. Yes, sir, number children. Do you know the definition of a circle? Yes. Now, if you paste a string along the diameter of a circular disc and rotate it as you had rotated the triangle in the previous section, you see a new solid. See the figure 13.18 mentioned. See here a circle. For a circular disc, we have pasted a string and we rotated as we had rotated a triangle in the previous section. We got a right circular cone. Yes, sir, mentioned. Now, if you observe this one, it resembles, it looks like a ball. Yes, sir, mentioned. Yes, it is called a sphere. Okay, my children, understood this point, what is meant by a sphere? Right. Can you guess what happens to the center of the circle when it forms a sphere on rotation? Of course, it becomes the center of the sphere. The center of the circle becomes the center of the sphere. So, a sphere is a three-dimensional figure or a solid figure which is made up of all the points in the space which lie at a constant distance called the radius from a fixed point called center of the sphere. Okay, my children, it is a solid figure. It is a solid sphere is a solid figure. Okay, my children, the center of the circle is the center of the sphere, and the radius of the circle becomes radius of the sphere. Okay, my children. Note, please remember this point, my children. A sphere is like the surface of a ball. Okay, my children. The word solid sphere is used for the solid whose surface is a sphere. Okay, my children, understood this difference between a sphere and a solid sphere? Right. Now come to the point surface area of a sphere. In this slide, we are going to discuss surface area of a sphere. To find the surface area of a sphere, let us do this activity. Okay, my children, have you ever played with a top, or have you at least watched someone play with one? Yes, you must be aware of how a string is wound around it. Now, let us take a rubber ball and drive a nail into it. Okay, mention, see here, a rubber ball is taken. Here a nail is kept into it. Taking support of the nail, let us wind a string around the ball. Okay, my children, here we have to take a string and we have to wind it around this ball. When you have reached the fullest part of the ball, use pins to keep the string in place and continue to wind the string around the remaining part of the ball. Okay, like this we have to wind that string to the fullest part of the ball till you have completely covered the ball. See this figure 13.19a, this figure. Okay, my children, mark the starting and finishing points on the string. Okay, my children, and slowly unwind the string from the surface of the ball. After marking the starting point and finishing point on the string, we have to unwind. We have to remove that string from the ball. Now you measure the diameter of the ball. Okay, my children, from which you can easily get its radius. Yes, my children, if you find diameter of the ball, automatically you can easily find the radius of the ball. Then on a sheet of paper, draw 4 circles with radius equal to radius of the ball. Okay, my children, on a sheet of paper, let us draw 4 circles with the radius equal to radius of the ball. Okay, my children, start filling the circles one by one. Here, fill this circle by that string. With the string, you had wound around the ball. Okay, my children, if you observe this activity, okay, my children, then what do you observe? Let us see. After performing this activity, what you have achieved in all this activity? Yes, the string, which had completely covered the surface area of the sphere, has been used to completely fill the regions of 4 circles, all of the same radius as that of the sphere. Okay, my children, if you observe that activity, that string fill that 4 circles completely. So what does that mean? This suggests that the surface area of a sphere of radius r is equal to 4 times the area of a circle of radius r. Yes, children, that is equal to 4 into what is the area of a circle formula? Pi r square. Okay, my children, this is the surface area of a sphere. Please remember this formula, my children. Well, okay, my children, right. So surface area of a sphere is equal to 4 pi r square. Memorize this formula well, my children, where r is the radius of the sphere. Okay, my children, right. How many faces do you see in the surface area of a sphere? Yes, there is only one, which is curved. Yes, sir, my children. In the case of cuboid, there are 6 faces. Yes, sir, my children. Right. In the case of right circular cylinder, 2 faces, 2 types of faces: circular face and curved surface. Curved surface. Yes, sir, my children. Right. In this slide, we are going to discuss hemisphere. Okay, my children. Now, let us take a solid sphere and slice it exactly through the middle with a plane that passes through the center of the sphere. What happens to sphere? Yes, it gets divided into 2 equal parts. See the figure 13.20, my children. See here, a solid sphere was cut by a plane which passes through the center of the sphere. Then we get 2 equal parts of the sphere. What will each of be called? Yes, it is called a hemisphere, because hemi also means half. Okay, surface area of a sphere, how many faces does it have? Yes, a hemisphere has 2 faces. there is a curved face and a flat face, that is base. Okay, this is a flat face and this is a curved face. Understood this point, my children? Right. In this slide, we are going to discuss curved and total surface area of a hemisphere. Okay, my children. The curved surface area of a hemisphere is equal to half of the surface area of the sphere, which is 1 by 2 of 4 pi r square. Okay, my children. What is the surface area of a sphere? Yes, 4 pi r square. Then the curved surface area of a hemisphere is equal to half of the surface area of the sphere. Okay, my children, understood this point? Right. Therefore, curved surface area of a hemisphere is equal to, what will get here? 2 pi r square. 1 by 2 of means 1 by 2 into 4 pi r square. 2 ones, 2 times. By simplifying these two numbers, we get finally 2 pi r square. This is the curved surface area of a hemisphere. Please remember this formula, my children, well, and memorize this formula well, my children. Right. Where r is the radius of the sphere of which the hemisphere is a part. Okay, my children, here r is the radius of the sphere. Okay, my children. Now taking the two faces of a hemisphere, its surface area is equal to 2 pi r square plus pi r square. As I mentioned, this is curved surface area plus this is base area. What is the shape of a base? Yes, circle. Yes or no, my children? Then what is the area of a circle? Pi r square. Understood this point, my children? Right. So by adding these two areas, we get the surface area of a hemisphere. So total surface area of a hemisphere is equal to 2 pi r square plus pi r square. What will get here finally? 3 pi r square. Okay, my children, memorize this formula also well, my children. Okay, my children, right. To understand these concepts well, let us take some examples. In this exercise, we have discussed surface area of a sphere, that is one point, and the next one, curved surface area of a hemisphere, that is the second formula, and the third one is total surface area of a hemisphere. Yes, my children, you have to memorize these formulas well. Okay, my children, right. Now come to the example. Find the surface area of a sphere of radius 7 centimeters. Understood this question, my children? First of all, before solving the question, we have to read the question well. You have to understand the question well. Okay, my children, right. This question is related to a sphere. Okay, my children, and to find the surface area of a sphere. Okay, my children, right. Now come to the solution. The surface area of a sphere of radius 7 centimeters would be 4 pi r square. Okay, my children, do you remember this formula? Surface area of a sphere is equal to 4 pi r square. In this formula, let us substitute r value. What is r here? 7. So 4 into, what is the value of pi here? 22 by 7. This is not exact value of pi. Please remember this point, my children. Pi value is not exact value. Is equal to 22 by 7. It is an approximate value only. 22 by 7 is an approximate value of pi. Okay, my children. Don't forget this point. Into r is equal to 7 into r value is 7. Now let us simplify these numbers. Here 7 gets cancelled. Then what are the numbers left here? Yes, 4 into 22 into 7. By multiplying these three numbers, what will you get? 616 centimeters square, because this is the units of area. Yes or no, my children? Understood this point, my children? Right. Now let us take another example. Okay, my children, find the curved surface area and the total surface area of a hemisphere of radius 21 centimeters. Okay, my children, understood this question? What is this question related to? Yes, this question is related to a hemisphere. So immediately you have to Remember the curved surface area of a sphere and the total surface area of a sphere. Okay, my children? Right. Now come to the solution part. The curved surface area of a hemisphere of radius 21 centimeters would be 2 pi r square. Do you remember this formula, my children? The curved surface area of a hemisphere is equal to 2 pi r square. Right. In this formula, let us substitute the value of r. That is equal to 2 into pi. What is the value of pi here? 22 by 7. It is only an approximate value of pi. Into what is r here? 21 into 21 centimeter square. Okay, my children, understood this step? Right. Now let us simplify. Here 7 1 times, here 7 3 times. Yes or no, my children? Then what is the numbers left here? 2 into 22 into 3 into 21. So multiply all these 4 numbers. By multiplying all these 4 numbers, I have left that part. Please do the multiplication, my children. Please do the calculation part by yourself. Then what will you get? Finally 2772 centimeter square. Okay, my children, understood this solution part? Right. Now come to the second part of the question. What is the second part of the question? Yes, we have to find the total surface area of a hemisphere. What is the total surface area of a hemisphere? Yes, 3 pi r square. This is the formula to find the total surface area of a hemisphere. So in this formula, let us substitute the value of r. That is equal to 3 into, what is the value of pi here? 22 by 7. Every time, please remember this point, my children. 22 by 7 is not exact value of pi because it is an irrational number. Pi is an irrational number, but 22 by 7 is a rational number. Only for our convenience, we are taking pi is equal to 22 by 7. Okay, my children. Into 21 into 21. R value is 21. So we substituted. Understood this step, my children? Right. Now let us simplify. Here also 7 1 times, here 7 3 times. Then what are the numbers left here? 3 into 22 into 3 into 21. Multiply all these 4 numbers. Can you do that part, my children? Right. Then after multiplying these 4 numbers, what will you get? 4158 centimeters square. Understood this solution, my dear children? Right. Now let us take another example. Okay, my dear children. The hollow sphere in which the circus motorcyclist performs his stunts has a diameter of 7 meters. Okay, my dear children, understood this one? The diameter of a hollow sphere was given. What is asked here? Find the area available to the motorcyclist for riding. What is meant by this question, my children? Yes, we have to find the surface area of the sphere. Okay, my children? Right. Now come to the solution part. What is given in the question? Yes, diameter of the sphere, that is equal to d, is equal to 7 meters. Therefore, radius of the sphere is equal to 7 by 2. What is the 7 by 2 value? 3.5 meters. Understood this step, my children? This was not given. We have found. Understood this step, my children? Right. So the riding space available for the motorcyclist is the surface area of the sphere, which is given by 4 pi r square. Do you remember this formula, my children? Surface area of a sphere. Yes, 4 pi r square. This is also not given directly. Okay, my children, find the surface area of a sphere. We have to understand the question well, and we have to identify which was asked. Okay, my children, right. That is equal to 4 into, what is the value of pi here? 22 by 7 into, what is the value of r here? We have found 3.5. So 3.5 into 3.5. Okay, my children, understood this step, right? Now let us simplify these numbers. Here 7 1 times, here 7 0.5 times. 0.5 times. Then what are the numbers we got here? 4 into 22 into 0.5 into 3.5. Can you multiply all these four numbers, my children? Right. I'm not doing that part. I have left for the part to you. Please perform that multiplication. Then what will you get here? 154 meters square. Understood the solution, my dear children? Right. Now let us take another example. A hemispherical dome of a building needs to be painted. See the figure 13.21. Observe this figure, my dear children. Observe this figure 13.21. This is a dome. The dome of this building. This building has two geometrical figures. Yes, my children. This base in the form of a rectangle and the dome of this building is in the form of a hemisphere. Yes or no, children? Yes. If the circumference of the base of the dome is 17.6 meters, find the cost of painting it. Given the cost of painting is 5 rupees per 100 meters square centimeter square. Understood this question, my children? Here, circumference of this hemisphere is given. We had to find the cost of painting it. Means here we have to find the curved surface area of this dome. Indirectly, it is asked that we have to find the curved surface area of this hemisphere. After that, we find the cost of painting it. Understood this question, my children? Right. Now come to the solution part. Since only the rounded surface of the dome is to be painted, we would need to find the curved surface area of the hemisphere. So now, my children, this point is not given. So now, my children, we have to observe the question. We have to understand the question well. Now, the question is related to find the curved surface area of a hemisphere. Okay, my children, to know the extent of painting that needs to be done. Okay, my children, understood this point? Right. Now, circumference of the dome is 17.6 meters. So, my children, this is given. Radius of the hemisphere is not given directly. So, we have to find it first. Therefore, what is the circumference of a circle? Yes, 2 pi r. Do you remember this formula, my children? Right. 2 pi r is equal to 17.6 meters. Understood this step, my children? Right. This implies 2 into what is the value of pi here? 22 by 7 into what is the value of r here? It was not given in the question. Okay, my children, is equal to 17.6. Understood this step, my children? From this equation, we had to find the value of r. Understood this point, my children? Right. This implies r is equal to, we had to transpose these two numbers to RHS. Then we get r is equal to 17.6 into here 2 becomes 1 by 2 into here 22 by 7 becomes 7 by 22. Understood this step, my children? Right. Here we had to simplify these numbers. Well, how do you simplify? Yes, 11 2 times here, 11 table here, 11 2 times, 11 2 times here, 11 1.6 times. Yes or no, my children? Yes. Again here 2 to 4, 2 into 2 4, 4 in how many times here? 0.4 times. Yes or no, my children? Yes, 0.4. So Finally, what will you get? 0.4 into 1 into 7. These are the numbers left. Can you multiply these three numbers, my children? What are the numbers left here? 0.4 into 1 into 7. Now multiply these three numbers. Can you multiply the numbers, my children? Yes. Finally, what will you get by multiplying these three numbers? Yes, 2.8. So this is radius of the hemisphere, 2.8 meters. We found the radius of the hemisphere. This was not given directly in the question. Understood this step, my children? Right. So after finding the radius of the hemisphere, we have to find curved surface area of the dome. Yes or no, my children? Because we have to paint that dome. So we have to find the curved surface area of the dome. That is equal to 2 pi r square. Do you remember this formula, my children? Curved surface area of a hemisphere. Yes. In this formula, let us substitute the value of r. In the previous slide, we have found the value of r. What is the value of r we got? Yes, 2.8. Okay, my children. Right. That is equal to 2 into, what is the value of pi here? 22 by 7 into, what is the value of r? 2.8 into 2.8 meter square. This is the units to denote the area of this curved surface area of this dome. Okay, my children. Right. Now, let us simplify these numbers as we have simplified. Here also let us simplify. See here, 7 one time, 7 table, 7 one time. Here, how many times 7? 0.4 times. 0.4 times. Then what are the numbers left here in the numerator? 2 into 22 into 0.4 into 2.8. Can you multiply all these four numbers, my children? Yes. I am not doing that calculation part. I left that calculation part for you. Will you do that multiplication, my children? Right. Now, after multiplying these four numbers, finally what will you get here? 49.28 meters square. Understood this step, my children? Right. Now come to the cost of painting. 100 meters per 100 centimeters square is equal to 5 rupees. It is given in the question itself. Cost of painting per 100 centimeters square is 5 rupees. Now cost of painting for 1 meter square is equal to 500 rupees, because 1 meter square is equal to 100 into 100 centimeter square. Do you remember this relation between meter square and centimeter square, my children? Right. So we have found this one, the cost of painting per 1 meter square, because we have found the curved surface area of the dome in terms of meter square. That is why we are converted this cost of painting in terms of meter square. Understood this step, my children? Right. Therefore, cost of painting the whole dome is equal to 500 into, what is the curved surface area of the dome? 49.28. Understood this step, my children? Right. Now multiply these two numbers. Can you multiply these two numbers, my children? Right. I'm not doing that multiplication. I have left that calculation part for you. Will you do it, my children? Right. That is equal to, by multiplying these two numbers, what will you get here? 24,640 rupees. Understood this solution, my children? Right.